Okay, we're going to look at interpolation now with regard to heights of low and high water. And in this problem earlier we looked at the times for Peel, and we looked Peel up, we realised that Liverpool was the standard port and we got the times corrected. So now we're going to correct the heights. And on the 5th of October, 07:45 is the time we require GMT. We looked up the heights of low water and high water for Liverpool, and we got 1.2 and 9.0. So that's low water and high water at Liverpool on the 5th of October. The first correction we need to apply is what's known as the seasonal change. Now, the seasonal change has already been allowed for in the tables for the standard ports. So whatever value you get from the tables, you need to change the sign. So when we talk about seasonal change, these are written at the bottom of the tide tables at the back. So when we look for Liverpool, we've got our ATT number of Liverpool as 452. So we go down to the bottom and we look for the value 452, and we can see it falls between 445 and 464, and then the month is October, so we go right through to October and we can see that the actual correction is 0. So we don't need to change the sign. Had it been in November and we've got plus 0.1, we would have called our correction minus 0.1. So when it's a standard port, you always change this sign. Don't make a principal error by not changing the sign. So we've put here seasonal change 0. No, we looked at the bottom there and we could see that it was 0, so we put 0 in here. Now, if the numbers aren't at the bottom of the relevant page here, it may be that they're on the previous page. So if you can't find your ATT number of your port on the same page, look on the previous page. It may well be there, but it will definitely be at the bottom under seasonal changes, and it's got all the months of the year there. Okay, so now we've got our predictions after applying the seasonal change. What we need to do now is calculate the second report, the difference for Peel. Okay, so if we look in the tables here, along the top for Liverpool, we can see the values: mean high water springs, mean high water neaps, low water neaps, low water springs. So in other words, height differences, high water and low water. For Liverpool, springs 9.3 down to neaps 7.4, 2.9 neaps down to 0.9 springs for low water. If we go down to Peel, we can see here we've got corrections for Peel, saying -4, -3.2 on the corresponding columns, -0.4, -2.9. So had our high water been 9.3, then the correction we would have done was -4. Had it been 7.4, we'd have just put -3.2. But as you can see, it's 9, our high water is 9, so it falls somewhere between 7.4 and 9.3. So our correction for Peel must fall somewhere between -3.2 and -4. So it's a case of interpolating and finding the value. Okay, so we've written here for low water interpolation, we've written the low water values, and we've got 0.9 and 2.9 for low water, so we've written 0.9 and 2.9. For Peel, we've got -0.4 and -1.4. I'll just see if I can adjust this so you can see them both. So for Peel, -0.4 -1.4, which corresponds to 0.9 and 2.9. So we've written here 0.9 and 2.9, which is the springs and neaps value, low water for Liverpool. Corresponding ones for Peel, -0.4, -1.4. Difference between this one is 2, difference between this one is 1. We require 1.2, which is somewhere between 0.9 and 2.9. So all we've done we've called our difference 0.3, which is 1.2 minus 0.9. Okay, so we want 1.2, so we've gone from 0.9 towards 1.2. So we have 0.3 over 2, which is the difference, multiplied by 1, which is the difference between our two values for Peel. We get a value of 0.15. So we apply the 0.15 to the Peel value. We're going from minus 0.4 to minus 1.4. So therefore we must mathematically add the 0.15 to the minus 0.4. So it's actually minus 0.55. Minus 0.4 towards 1.4. It must be more than minus 0.4, more minus value. So it's minus 0.55. So low water, the difference here, we write minus 0.55. Let's look at high water by interpolation. Again, going to the tables, high water, Springs and Neeps 9.37.4, going down to Peel, minus 3.2 minus 4, so we must be between these values. So we've written 9.3 and 7.4, minus 4 minus 3.2. Got the differences, 1.9 between the two values here and 0.8 between the Peel values. We require 9, which is somewhere here. So 9.3 minus the 9, that's 0.3, the difference. So if we put 0.3 divided by 1.9 multiplied by our difference, it gives us a correction of 0.12 to apply to one of these values. We're going from 4 down to 3.2, so our correction is 0.4 less this 0.12, so it becomes minus 3.87. So the correction for high water is minus 3.87. So we can write in here minus 3.87. Okay, so we can do those sums. So we now have values there that we've corrected for Peel, and now we need to allow the seasonal correction for Peel. When we looked at these initially, we allowed a seasonal correction for Liverpool, and we looked down at the bottom and we realised it was 0, and we changed the sign. We must change the sign for a standard port. For a secondary port, you don't change the sign. You allow it as it is down here. So Peel is 466. So we go down and we can see here the value 466 to 478. So we go along 466 to October and we can see it's 0. So there's no correction to apply there. Had there been a correction of say plus 0.1, we would have allowed plus 0.1. So what we've done now, we've calculated the heights of low water and high water for Peel to use on our tidal graph to calculate the 0745 height at Peel. So we've initially started off with the heights of low water and high water for Liverpool. We've gone through the corrections and we've ended up now with low water and high water for Peel. Just a point to consider here. When we're dealing with secondary points and we're interpolating, we also need to extrapolate if necessary as well. And that's if the value that we have here, say our value 1.2, had been outside of the range, say our low water had been 0.7, would have been less than 0.9, we would have had to extrapolate to get the correction. So we either interpolate or extrapolate. When it's a standard port, you only interpolate, but extrapolation is necessary for secondary ports. So that's how we get the heights of low water and high water aligned for the corrections. So we started off by a line for the seasonal change for Liverpool, always change the sign. Then we calculated by interpolation the correction for Peel for the secondary port. Then we allowed the seasonal change for Peel, and then that gave us the heights of high water and low water for Peel.